Hey guys, welcome back. This is part 2 of the 8.4 notes. So we're going to go ahead and pick up where we left off, looking at example 2. Now, it does say calculator allowed, so that's going to be important, right? Whenever it says that, we want to make sure we have our calculator available to us. So let's read the question. Given the velocity of a particle, the velocity of a particle is represented by v of t, which is 9.2 t cubed minus 3t squared minus 8. We're going to answer some questions. First one is to find the total distance traveled by the particle on the time interval from 0 to 6 seconds. So the first thing is making sure you remember how to calculate total distance. Total distance is going to be, now pause the video, see what you do on your own, and then come back and check it out. But it's the integral from 0 to 6 of the absolute value of the velocity function. So for total distance, we need to make sure it's, sorry, the phone's ringing, so I'm going to answer. All right, guys, sorry about that. But anyway, so total distance is the integral of the absolute value of velocity. And all I need to do is write it like that when I can use a calculator. From there, you want to pull up your calculator, and we'll talk about how do you put that into the calculator. So we want to do, well, the first thing I'm going to do, because we're going to actually use that function multiple times, I'm going to go ahead and store v of t real quick. So we've got v parentheses t. And then to store the function, we're going to go control, and then this little menu, so it's got the colon equal sign. So our function was 9.2 times t to the third power. You got to get out of the exponent there. And then that's minus 3 times t squared. And then we got minus 8. Hit enter. It should say done over here on the right-hand side. All right, so what we wanted was the integral. So I'm going to go ahead and go menu, calculus, integral. I know there's a quicker way to get there. I think it's shift plus or shift minus. But we got the integral from 0 to 6. All right, and then in order to get absolute value, you can find it a couple ways. You can type in ABS, or I believe you can just click on the little open book, and it's the first thing there. So however you do it will work. And then you've got v of t, because we stored that function, dt, hit enter, and we should get our answer. Now, let me go through here real quick, guys, and I want to change my settings to make sure that I'm getting the proper number of decimals. So if I go menu, actually I need to go back to the home screen here real quick. So if I go home and settings, we want to go document settings and change that display digits to fixed 5. That's going to guarantee that I get 5 decimal places each time. Angle measures needs to be in radians, and the rest should be good. All right, so let me go back, and I'm going to just hit enter one more time. All right, so when I look at this, obviously it wasn't just 3, 4 exactly. So with College Board, they want everything to 3 decimal places, so that could be rounded or truncated. In this case, it's going to be the same whether you round or truncate. So it's 2730.341. So if we go here, we got 2730.341, and that would represent the total distance traveled in this case. For part B, it's asking about total displacement. So total displacement basically refers to how far are we from where we began. And that's going to be found taking the integral from 0 to 6 of the velocity function itself. So in this case, positive and negative velocity will essentially cancel each other out to get us where we end up. And I did not spell displacement right. Sorry about that. All right, so then if we pull up the calculator again, all right, the nice thing about storing the function is now all we got to do is if we go menu, calculus, integral, we're still going from 0 to 6. We don't have to type everything in again. We just go v of t, and then dt, hit enter, and there we go. We got 2716.800. So 2716.800. Whoops. So 2716.800. All right, the next thing. It says, given that t is greater than or equal to 0 and less than or equal to 10, we want to find any times that the particle changes directions. So you want to think about, okay, when does a particle change, or how do you know when a particle changes direction? Basically, we need to know when does v of t change signs. That's what we are looking for. So because we have our calculator available to us, the easiest thing to do is to just go ahead and graph that function. Now I should be able to just, it's not going to, well, what happens if I do v of x? Okay, it does work. So I want to just kind of mention something as when you enter that function, if you go, graph entry edit with a function, the input variable here is x. So if I would have typed in v of t, it wouldn't have recognized it. All right, but because I did v of x, there's our function. All right, from 0 to 10, it's only changing signs this one time. So we need to figure out what that coordinate is. So you can basically go menu and analyze the graph, and we're going to look for zeros. Where does it cross the x-axis? We can just kind of click 1 point here, 1 point here. All right, now I did not change the settings in my graphing, so I'm going to go ahead and do that real quick. Menu, settings down here with 8. And again, you just want to make sure you change that display to fix 5. So click OK. And there we go, 1.07648. And if we're rounding or truncating to 3 decimal places, that's 1.076. So t equals 1.076 is the answer. All right, for D, it says given that the initial position of the particle is 3.2, we want to find the position of the particle at t equals 7. So in order for us to find the position, the new position at t equals 7, we need to know where we're starting, which is that 3.2. And then we need to know the displacement, basically. How far did we end up from where we started? So we're going to use the displacement, not the total distance. All right, so we're going to take the integral from 0 to 7 of v of t dt, because that will give us the amount of change. Again, we've already stored v of t in the calculator, and that makes it very easy for us to type this in. So if we go back to the calculator, we're going to go back to that scratch pad. So we've got 3.2, and we're adding the integral. This time it's from 0 to 7, v of t dt. Hit enter, and there's our answer, 5,126.500. That would be the new position. So quite a bit of change in the distance over that time. So we get 5,126.500. All right, let's go ahead and take a look at example 3. So if h of t is the rate of change of the height of the conical pile of sand measured in feet per hour, what does the integral from 0 to 5 h of t dt represent? And we want to give that answer in correct units. So I would try this on your own. See what you come up with. All right, since h of t is a rate of change, okay, and it's the rate of change of the height measured in feet per hour. If we integrate h of t from 0 to 5, that's going to represent the amount, or basically the total change. So the total change in height of the sand pile measured in feet from t equals 0 to t equals 5 hours. All right. So there's some things you want to make sure you in there. It's the total change in height, all right, of the sand pile. It's measured in feet, and the limits of integration from 0 to 5 represent the time from 0 to 5, and time is measured in hours. So you really need to make sure you have all of those pieces within there. All right, we got one more. We'll take a look at example 4, and that'll be it for the video. So it says the graph of f prime on the closed interval from -2 to 6 consists of 2 line segments and a semicircle as shown at the right. Given that f of -2 is 5, we want to find f of 0, f of 2, and f of 6. So one thing that's kind of important is you understand that this is the graph of f prime. So we're looking at the derivative, the rate of change of f. If we integrate a rate of change, we get the amount of change. So starting with f of 0, we can find f of 0 if we take this starting value, right? This basically is our initial value, or the starting value. So f of 0 is going to be f of -2, and then we're going to have to add the amount of change from -2 to 0 of the f prime. So we know that f of -2 is 5 plus. The way that we're going to go about calculating the integral from -2 to 5 is we're going to use the graph, and we're going to calculate the area under the curve from -2 to 0. So that's that triangle right there, which is 1/2. The base is 2, and the height is 1, 2, 3, 4. And we simplify that, we get 9. So that is one way to go ahead and find f of 0. The next question wants us to find f of 2. Now, this can be done a couple of ways. We can find f of 2 starting at -2. Or we could find f of 2 starting at 0 because we now know this value. And that's what I'm going to go ahead and do, so we don't have to kind of find an integral that we've already done or find area that we've already done. So I'm going to go ahead and think of this as f of 0 plus the integral from 0 to 2 of f prime with respect to x. So again, we found out that f of 0 was 9, and then when we add the integral from 0 to 2, we're going to add this area, which is 1/2, the base is 2, the height is 4. So 9 plus 4 is 13. So f of 2 is simply 13. All right. I will show an alternative way to find f of 2 at the end of the video, but that's one way to do it. And then for f of 6, all right, that's the last thing that we got is f of 6. I'm going to go ahead and use f of 2. So f of 6 will be f of 2 plus the integral from 2 to 6 of f prime of x dx, or just, I guess, f prime dx, however we want to think about it. Well, we know that f of 2 is 13. Now, this time, when we look at the graph from 2 to 6, we have this area, which is a semicircle, and it is below the x-axis. So the fact that it's below the x-axis means the area is going to be negative. It's a semicircle, so we're taking half the area of the circle, which is half of pi r squared, and in this case, the radius is 2. So if we simplify that, we're going to get 13 minus 2 squared is 4, half of 4 is 2, so 13 minus 2 pi, and that's f of 6. All right, so I mentioned that I was going to go ahead and show you guys one additional way to find f of 2. So another way to potentially find f of 2, all right, let's just try to block this off here. So another way to think about f of 2 is using that initial value of f of negative 2, we could do f of negative 2 plus the integral from negative 2 to 2 of f prime dx. And again, f of negative 2 is 5. The only difference if you did it this way is now we're taking the whole integral from negative 2 to 2, which would be the area of this entire triangle here, which is 1/2. The base is now 4. The height is 4. So basically, half of 4 is 2. 2 times 4 is 8. 5 plus 8 is 13. You get the exact same answer. So you have alternatives, you have methods. It just, for me, I didn't want to go ahead and recalculate something that I had already done before. You know, and you're just going to have to decide if that's something you have to do or if you want to do. All right, guys, that is it for part 2 of the 8.4 video. Hopefully this helps you out. See you next time.